So hello everyone. My name is Utkal Roy. I'm from IT Delhi, right? In this class, we'll talk about sequence and series, right? So we have two subsections of this chapter, which I'll introduce to you. First is I'll talk about AP and GP, and in the next part of the session, I'll talk about the sum and the nth term formula, how to get it, how to memorize it, everything. And also we'll practice few questions if we get the chance, right? Okay, let's get ahead with the topic. So to know about AP and GP, first of all, we have to know the clear definition of what is a sequence and what is a series, right? So I'll write the definition of sequence here in front of you. Sequence. Yeah. So what is a sequence? A sequence is nothing but a succession of terms formed according to some rule or law. That can be anything, right? Not necessarily a fixed pattern. It can be any rule or any law, any relation between all the terms. Let me write the definition. A succession, right? A succession of terms formed according to any rule or law. And the rule or law can be anything. For example, if I talk about perfect squares, 1, 4, 9, 16, 25, what are these? These are nothing but perfect squares of natural numbers, right? So this can be also known as a sequence because there is some relation between them, right? So this is a sequence. Another example, -1, +1, -1, +1, dot, 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 dot. Is it a sequence? Yes, it is a sequence because every next term is nothing but if you multiply the initial term with -1, you'll get the next term. That is -1 into -1 is +1. +1 into -1 is -1. -1 into -1 is +1. So every term you're just multiplying by -1. So there is again a specific relation, right? So this can be also termed as sequence. If we go to, for example, let's talk about x upon 1 factorial, x square upon 2 factorial, x cube upon 3 factorial, right? Is it a sequence? Yes, it is a sequence because here also you can see a specific kind of relation. That is the numerator, the power of numerator has been increased after each step and the denominator factorial is also increased by one number. So this can also be called a sequence, right? Now there are two types of sequence. One is a finite sequence, other is the infinite sequence, right? Infinite sequence. As the name suggests, it is very easy to understand what is a finite sequence and infinite sequence. A finite sequence is a sequence where the terms are finite, and infinite sequence is a sequence where the terms are infinite. For example, here there are only three terms, so this can be termed as finite sequence. And here, as you can see, that there are extra dots which emphasize that this series is never ending. So this will be an example of infinite sequence. Very easy to understand, right? Now, we got the meaning of the first word of our chapter. What is the second word? Series. What does a series mean? Again, I'll start with a definition to make it very clear to all of you. Series. Right. Now, what is a series? A series is nothing but the indicated sum of all the terms of a sequence. Right. For example, here you saw individual terms separated by commas. Now, if you add all the terms together, it will be nothing but a series. Right. The indicated sum of all the terms of a sequence of a given sequence is a series. Very easy, right? Now, if I talk about any sequence, for example, A1, comma A2, comma A3, comma A4, comma A5, dot, 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 AN, right? Now, for this to be a sequence, there should be a specific relation which every term is following, right? You guys know it, right? Now, what will be a series? A series is nothing but if we just add all the terms of sequence. For example, A1 plus A2 plus A3 plus A4 plus A5 dot 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 plus AN. This will be a series, right? And it can be also written as summation n equals to 1 to n A n, or you can write this as k equals to 1 to n A k. This is nothing but just a way to denote, right? For example, summation means adding all the terms, pi means multiplying all the terms. So what does this mean? This means that if we put k equals to 1, it will be A1. If we put k equals to 2, it will be A2. If we put k equals to 3, it will be A3. Dot dot dot. If we put k equals to n, it will be AN. Now, as there is summation sign means we have to just add all the terms, right? So this, if I write anything, for example, Bn, k equals to 1 to n, Bk, sorry. This will be nothing but B1 plus B2 plus B3 dot 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 Bn, right? If I talk about pi, k equals to 1 to n Ck, it is nothing but as it is a pi, terms will be multiplicated, right? So it will be C1 into C2 into C3 dot 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 Cn, right? So which one is a series? This one is a series or this one is a series? Series is this one, right? Because as the definition suggests, it should be sum, not multiplication, right? Yeah. Now I guess sequence and series is very clear to you, right? For all of you. Now we'll start talking about what is specifically AP and what is specifically GP, right? Let's start with AP, right? What is AP? You must be aware of the full form. It is nothing but arithmetic progression. Arithmetic progression, right? What is the definition of an AP? The definition is very simple. AP is a sequence whose terms differ by a fixed number, right? AP is also a type of sequence whose term differ by a specific number or a fixed number. This is very important to notice that number should be fixed, right? It shouldn't be changing after every term. It should be a fixed number. So I'll highlight this term by a fixed number, right? And in maths, this fixed number is also termed as common difference, right? Common difference. Now I'll show you a few examples, right? So the fixed number by which it differs, it is known as common difference. And the first term of an AP is also denoted by a letter that is A in mathematical terminology, right? The first term of an AP is denoted by A. And generally common difference is denoted by D, right? Yeah. Now, I'll give you a few examples. You have to tell me if it is an AP or it is not an AP, right? I'll give you very easy. For example, let's take an example of 1, 2, 4, 7, 11, right? Now, is it an AP? Pause the screen, think about the definition, and now think about your answer. I'll tell you the answer right now, right? Here, what is the definition? Definition is AP is also a type of sequence where terms differ by a fixed number. Now let's see the difference. The difference between 1 and 2 is 1. The difference between 2 and 4 is 2. The difference between 4 and 7 is 3. The difference between 7 and 11 is 4. Is the difference same or constant? The answer is no. So it is not an AP, right? Second example, 0, 2, 4, 6, 8. Is this an AP? Again, go by the definition, check the difference. Difference between this is 2. Difference between these two terms are 2. 2, 2. So yes, here the common difference D is constant, right? Hence an AP. Got it? Right? So an AP can be also formalized by, if I want to write a generalized way of writing an AP, what I'll write is, as we know, the first term is denoted by A. So I will write the, so let me write a general form. general form, right? As we know, the first term of an AP is known as A, right? What will be the second term in terms of letters? It will be A plus D, right? D was the common difference, if you guys remember, right? A plus D. Third term would be, you just need two things to make the whole sequence, the first term and the common difference. Because once you get the common difference and you know that the common difference will stay constant throughout, you have to just add the common difference after each term and you can get the new term, right? So A, comma A plus D, comma A plus D will be the next term. Then the next term would be A plus D plus D plus D, right? Dot, 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 dot. Now, it can be written as A plus D, A plus 2D, A plus 3D, right? This is the generalized form of any AP, right? I guess all of you got what AP is. Now we'll talk about GP, right? Here I'll give you a basic introduction of all the topics, right? But you can anyway, personally message me via Urban Pro and we can have a proper class of all the chapters I'll introduce you about, right? Let's talk about GP. GP is nothing but geometric progression. Right. What is our definition of geometric progression? Geometric progression is also a sequence like AP, right? Of non-zero numbers. Here you have to keep in mind the numbers should be non-zero in the sequence, right? I'll mention it in the definition. Each of the succeeding term is equal to the preceding term multiplied by a constant, right? This is the basic difference between AP and GP. In AP, you have to add a common difference to get the new number. But in geometric progression, you have to multiply the old number by a constant. Here again, the multiplication number should be constant, like the common difference. The only difference is here, we're multiplying it instead of adding it. As simple as it gets, right? Let me write the definition here. GP is also a sequence. GP is also a sequence of non-zero numbers to keep in mind. Non-zero numbers. Right? Non-zero numbers. Each of the succeeding term of the following term, each of the succeeding term, right, is equal to the preceding term, right, multiplied by a specific constant. In maths terminology, the specific constant is also known as common ratio, right? As it was common difference in the case of arithmetic progression is known as common ratio. And it is generally denoted by R as the ratio, right? Right? Any doubts? I don't think so, right? And again, the first term of a GP is denoted by A, right? Here it stays constant. I'll give you a few examples of GP. You have to tell me if it is GP or not. 1, 2, 4, 8, 16, 32. Is it a GP? Go back to the definition. GP is also a sequence of non-zero numbers. Is there any zero? No. Okay, satisfied. First condition. Non-zero numbers. Each of the succeeding term is equal to the preceding term multiplied by a specific constant. Right here. 2. 2 is a number. If you multiply 1 into 2, you will get 2. 4. 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. 16 into 2 is 32. So yeah, here the ratio stays constant, that is 2. So this can be termed as GP. Yes, it is a GP. Second example, 1, 3, 6, 12, 36. Tell me, is it a GP or it is not a GP? Pause the screen, think about the answer, and then resume it again. Now, I'll tell you. If you see the common ratio, it is into 3. Here it is into 2. 3 into 6. 6 into 12. Again, 12 into 3 is 36. Is the common ratio same in all the cases? The answer is straight away no. So this is not a GP, right? Now we'll talk about the generalized form of a GP. Now, we all know that the first term is denoted by A. What is the next term? The next term is the first term multiplied by a common constant, which is also known as common ratio and which is denoted by R. So next term will be nothing but A into R, right? What will be the next to next term? It will be A R into R, right? What will be the other term? A R into R into R. Right? Just multiply R, keep multiplying R to get the next terms. It can be also written as A R square, A R cube, right? This is the first term, second term, third term, fourth term, right? I guess it is clear to all of you what is AP and what is GP, right? Now the first part of the session gets over. Thank you very much, right?